Okay, good morning, everyone, and thank you for joining our webinar on how to win the war against labor shortages and future-proof your plant. My name is Derek Von Cannon, and I am the Vice President of Sales for Afinitas. For those of you who don't know, Afinitas is a major provider of equipment and services to the precast concrete industry and the parent company of Hawkeye Pettershad, BFS, New Hampton Metal Fab, Spillman, and CAM Products. Today, we have a few housekeeping items to mention. You'll be muted during the presentation, but can submit questions through the chat box. We will take as many questions as time allows after the presentation. Also, we are recording the presentation, so you will receive a follow-up email with a link to the replay and a PDF of the slides. We have an interesting discussion lined up for you today, presented by our partner, Hermann Weckenmann of Weckenmann Company in Germany. Just to give you a little background about Hermann, his father started Weckenmann in 1957 as a metal, machinery, and technology company. Hermann joined the team in 1983 as a mechanical engineer. He and his brother Wolfgang became managing partners in 1989, ushering in a new generation of leadership where they have designed, consulted on, and manufactured equipment for hundreds of plants worldwide. Hermann has been published in several magazines and holds a number of patents. And as his customers have stated, some you'll hear about today, he is remarkably in tune to the needs and wants of U.S. precast manufacturers. So without further delay, take it away, Hermann.
Welcome to everybody to today's topic, how to win the war on labor shortages and future-proof your plant, or how to make our industry prepared for the next decade. In this webinar, we will discuss the following topics: who is Weckenmann, today's challenges, the manufacturing labor shortage is still coming. 2 US precasters made the leap. Stationary production, circulation line, outlook, and discussion. Who is Weckenmann? First, some information about our company. Founded in 1957, we have about 150 employees. Our customers are worldwide. Our location is in the southwest of Germany, near Stuttgart, or for those who know that, the Black Forest. We are an international technology leader. We made some invention, for example, the shuttering robot or concrete spreader, the automatic concrete spreader is invented by us. We are thinking and acting globally. So we do have a lot of international customers, and the success of our success is a combination of high product quality and a focus on each country's specific requirements. Our machines and equipment is really long lasting, 20 years and more are they in use. And we have a high manufacturing standards in 2 production plants. And to bring it in one sentence, Weckenmann is 100% dedicated to the precast concrete industry. Yeah, today's challenges. First, the customer expectations. Better, faster, more cost efficient. We have to be better, faster, and more cost efficient to gain more market shares. Digitalization. Digitalization is an advantage and a precondition for industrialized construction, and that's the future. The environmental requirements, energy consumption, waste reduction are some headlines. The reduction of the carbon dioxide footprint will be an important competitive advantage in the future for our industry. Health and safety. To keep our employees healthy and safe should be out of discussion. And the shortage of skilled labor, we have to overcome our not the best image of the industry. I heard once the description of a triple D, dark, dirty, and dangerous. The precast concrete industry has a big chance to make their jobs much more attractive, well paid, modern, and safe. The manufacturing labor shortage is still coming. Stay prepared. Estimates put the manufacturing labor shortage at 2.54 million by 2028, according to Deloitte. And we can't assume this gap will be solved by a sudden influx of employees after COVID-19 restrictions are eased. The number of retirees continues to increase as the working population ages, meaning there will still be a lack of sufficient qualified applicants to replace them. And that's something we have to discuss today. How to increase efficiency in the precast concrete industry or in the precast production. Early detailed production and resource planning to optimize work and material flow. Then we have reduced waiting time because drawings, data, material, equipment are not available in time. And this is a huge possibility really to improve the efficiency. And there's a chance to invest in equipment to substitute time-consuming, monotonous, or complex manual work. Where are the greatest potentials to reduce manpower in precast production? First, we have the formwork. Magnetic side rail, blockouts, and other standardized formwork helps a lot. Or do you still use a lot of wood and polystyrene? Set up side rails and other formwork. Is the measuring tape your current technology? But there are plotter, laser protection systems, and shuttering robots available to do that. Cleaning and oiling the forms. Is a scraper or broom or compressed air your tool to clean the molds? Cleaning and oiling machine can really help to improve productivity. Reinforcing. Rebar straightening machines, wire mesh welding plants, or rebar placing robots can help to reduce the manpower. And everybody can imagine how much time it needs to reinforce with rebars and standard wire mesh, not mention the waste. Concrete supply and casting. There are concrete spreaders available or traveling buckets. And when we see what is in many factories the normal way to bring in concrete by truck mixer or forklifter, and then poured and distributed by too many workers shoveling and bringing the concrete to the right place. We have the surface treatment. Power troweling machines are available, or automatic washing machines and something like that. It's more safe to use such a machine, and it's faster and more productive than standing on the bed using a mobile troweling machine, which is really time consuming and dangerous. Service and maintenance helps reduce manpower. Although you need manpower to do service and maintenance, but if the machine has a simple and robust design or a remote access to control system, or when you use and do predictive maintenance, the availability of the equipment gets really increased. And we have the digital processes. Hard and software are available to digitalize all processes from design, procurement, manufacturing, transport to installation. And we should not see anymore or that often that people running around with a bunch of papers, because that isn't really future proof. Yeah, we have which production method is really the right way? Is it stationary production or is it circulation line? Is stationary production old style, or is the circulation technology the future? Let's talk about differences and advantages of those two systems. First, we have the circulation line. The advantages are the following. First of all, the work comes to the worker. That means everybody stays at a certain station, less running around. You have dedicated working places. There are high automation opportunities. Those circulation lines can really start with a basic technology or basic equipment, but it's easy to upgrade. Easier to upgrade than in a stationary line. We have good workplace conditions. For example, temperature and light can be controlled. Its health and safety are more guaranteed, and material and tools are within the reach. We have targeted material flow. The way in and out for all material are clear. We have dedicated storage areas. It's energy sufficient. For example, when you think about the curing chamber, which is insulated environment where you have controlled temperature and humidity. The circulation system allows a better production control. For example, data about the material consumption, working time, curing time, status of each job is on time available. And it is less space consuming, because in the curing chamber, that technology, the circulation technology, uses the third dimension, because the pallets are stored one above the other. Coming to the advantages of a stationary production line, of course, long beds are for pre-stressed products more suitable. The flexibility for different products to be manufactured is higher, because several teams can work on different molds simultaneously at the same time. The investment is lower, and that makes sense when the required capacity is smaller, because the circulation line needs a minimum production output per day to be efficient, cost efficient. And it is easy to install and easy to move to another place, just in case that's needed. Yeah. Why two US precasters made the leap into higher investment in modernization, in automation? And we have, or I will present two technology. One is a stationary line and one is a circulation line. Yeah, why two US precasters made the leap? Because they want to be ahead in quality and productivity. We started with a company, Kerkstra, in Kerkstra Precast in Trenton. They have a stationary production of double T and architectural wall panels. Kerkstra was founded in 1962. They operate two factories, one in Grand Rapids, Michigan, and one in Trenton near Detroit, Michigan. Their product range goes from hollow core slabs, columns, beams, double Ts to wall panels. Yeah, their stationary production, they have, or they produce in that plant in Trenton, prestressed solid and insulated architectural wall panels in double T's. They have a double T bed, 500 feet long, and 3 flat slab beds, 15-4 wide. Their stationary production, the investment has been made in 2018 and 19. They invested in a set of machines, and in particular, it was a so-called CPO machine, a finishing machine, a utility cart, top cart, and a runoff cart. And I would like to show you these machines in action. First, start with a CPO machine. CPO stands for cleaning the beds, plotting the contours, and oiling the beds. That machine runs over the bed back and forth and executes all those processes in an automatic mode. Only the operator has to push a button at the beginning, and everything else then happens fully automated. You can see very visible plotting lines where to place later on the bulkheads. Then we have the utility cart. The task of that machine is lifts the bulkheads up from the bed after stripping the double T's, pulls the strands and places the bulkheads on the bed. It's operated by one operator. He stands on the machine and travels with the machine all along the bed. So the bulkheads is set up by the machine along the plotting line, so very precise. Then we have the finishing machine. After casting the concrete, the finishing machine screeds the surface. It's brooming or brooming, finishing, possible raking, and power troweling. It depends on the requirement on the surface on the double T's. Then we have the top cart. 2 racks for the hoops are integrated, and that really allows a quick and easy removing and installation of the hoops and the top. The machine can move from one bed to the next, so from the double T to the flat slab bed by itself without a crane, just using rails on the floor. Then we have the runoff cart for the transport of double T slabs or wall panels by 2 identical carts, which run on the same rail track. The carts are battery powered, and the operation, or one operator controls the machines with a radio remote control system. Yeah, what are the achievements after this investment by Kerkstra? We have increased productivity. Plotting and cleaning, oiling is fully automatic, and it takes about approximately 1 hour for the 500 feet long bed. Strand pulling and set up bulkheads needs 1 worker, and it takes also about 1 hour. And screeding, brooming needs 1 worker in less than 1 hour. But here we have, it depends on the surface. Power troweling, of course, needs more time. But in general, this is really a very short time to do that. And just by one worker. We have less silica in the air because the kind of brushes and the vacuum system that's integrated in the CPO machine reduces the dust in the air. We have reduced consumption of foaming oil. The quantity of foaming oil sprayed on is very even and can be adjusted exactly to the supplier's recommendation. The machine does not know a Monday or Friday, so the machine applies the oil all the time in the same amount that's really needed and nothing more. We have high dimensional accuracy, no measuring errors. The data generated by the CAD system. If those data are correct, yeah, all the plotting lines are correct as well. And the plotter can really plot whatever is in the file. So even numbers or figures or letters or circles, there are no limitations. We have safer working conditions because less people working on the beds and less trucks driving around. And we have faster production in general. We come to the next sample or project. It's Molin in Ramsey, Minnesota. They have a circulation line for architectural wall panels. Founded in 1897, Molin is a designer, manufacturer, and installer of precast pre-stressed concrete components. Headquartered in Lino Lakes, Minnesota, Molin also operates an automated wall panel production facility in Ramsey, Minnesota. That's what we are talking about now. The product types there, solid and insulated architectural wall panels with many different surfaces or textures, fair-faced brick, water-washed, acid-edged, sandblasted, liner, almost no limitations. The pallet size, the gross size is approximately 13 foot wide and 40 feet long. They have 24 pallets in their plant, and the dimension of the maximum dimension of a precast concrete element is 12 by 39 by 12 inch. In the following the circulation line, the main components are, first they have pallets and magnetic sidewalls, rollers and friction wheels and cross-lifting trucks to move the pallets around in the factory, longitudinal and transversally. And they have a heated queuing chamber, an insulated queuing chamber with an automatic rack operator. So the bringing in the pallets in and out the queuing chamber is it's full automatic. Also, they have a CPO machine. The functions are the same as with the Kerkstra. Then they have a sideway cleaning and oiling line. They have a concrete spreader with 2 interchangeable buckets for face mix and gray concrete. It's very important when they do colored concrete or different face mix to avoid to wash all the time the bucket after each batch of concrete. Then they have 2 compaction line station. It's a shaking technology. Is very low noise shaking. It's a horizontal and low frequency system. Then they have a power troweling device. They have a tilting station, a finishing line, runoff truck, and everything is computer controlled. In the following, the individual product steps also shown in videos. It starts with cleaning the pallet by the CPO machine. That machine is also full automated. It goes over the pallet using a scraper and a brush. Then plotting starts. The data are being generated by a CAD system and transferred in DXF format to a master computer that organizes the production sequence and provides the plotter with the relevant data of each pallet, and that happens really just in time. And also here, there are no limitations on information you want to bring onto the pallet. Then we have oiling. So forming oil is being sprayed onto the pallet, also in a very even and consumption controlled way. Then we have the setup of the side rail. The positioning of the magnetic side rail is done by one operator by means of a very light crane, and he uses a plotting line to align or to place the side rail. Then the pallet moves further to the next station where the reinforcing of the first wipe happens. And then the pallet goes into the casting station. So casting and compaction happens on this one station. It's fast, precise. It's done by one operator using a radio remote control. And yeah, compaction happens with a shaking system, low frequency, and therefore it's really not noisy. Yeah, very comfortable for the workers there. Then the pallet goes back to the station where the insulation is built in, and it's followed by reinforcing the second wipe. That happens on the same station. And the preparation of insulation and the reinforcing just happens next to that pallet. So very short transport distances. Then the casting of the second wipe happens, also the compaction. And yeah, the concrete spreader is able to cast 1 cubic yard per minute. So that's really fast, and you can see the quality. The concrete comes out of the machine and like a carpet, so very even, and yeah, there's almost no manual distribution of concrete necessary. Then we have screeding, so the concrete gets leveled and additionally compacted. That results to really an accurate dimension and perfect surface. Also, raking is possible with that to get this special texture. And we have the power troweling. Also happens with one operator using a radio remote control. It can really get a very nice surface. Curing happens in the curing chamber. It's really fast curing because temperature and humidity are controlled, and therefore it's a very energy-saving environment. Then the sidewalls get demolded, stripped, using also a light crane, and the operator puts them on a conveyor. The conveyor ends in a sidewall cleaning and oiling machine to guarantee that the sidewalls could keep them all the time clean and always oiled, which is really important. And we have tilting and stripping. The tilting of the pallet reduces the amount of reinforcing. Yeah, because the tilt up is done different to when you just tilt it up on the bed, on a stationary bed, and it's also very safe to do that. And then the elements, the wall panels are transported by a run-off truck to the stockyard, or they go into a finishing line. It's a conveyor, overhead conveyor, and the panels go from one bay to the next one. It's a curved conveyor, and the conveyor ends up in a cabin where a special washing machine is installed. The washing machine can make different textures on the wall panel, and after that, the wall panel ends at the stockyard where the gantry crane takes over that wall panel, puts them in a rack or on the truck. Yeah, the output and productivity of such a circulation line at Molin, it's about 2 pallets an hour. So that means they can get 5,000 square foot a day. But that really depends on the final product. If you have just solid wall panels, very simple, just gray concrete, no insulation, the productivity or the output could be even higher. But when you do architectural concrete, that's a bit different. Yeah, the success of such a plant, John Weckenmann from Molin said, A typical precast production plant of this capacity would require 48 workers. Our new plant will need just 14 to 18. The whole production process is computer controlled. This means higher quality, more consistent products, and fast product availability. And this certainly pays off, and it did so. Molin is very successful. Now, what are the next steps? The precast concrete producers can't afford to be behind other manufacturing industries. And automation solutions are already available and in use to achieve cost down, quality up, delivery time short, which is the triangle of success for all of us. And here are some samples how the future could look like. What are the next steps? For example, using a shuttering robot. Shuttering robot places a magnetic sideways, arrow-free, 20 in a time of 20 seconds per piece, and really precise. We have a tolerance less than 1/10 of an inch. Or using an automatic concrete distributor. Automatic dosage of concrete at a tolerance of 2 to 5% of the weight. For example, very important when you do face mix or when you're casting face mix, expensive face mix, where the consumption of concrete really is a costly question, and that really can reduce the amount of concrete in for wall panels, for architectural wall panels. Or automatic wire mesh manufacturing to weld customized wire mesh up to 2,000 square feet an hour. That minimizes really waste because rebars are only there where needed. For example, here you can see a different grid of rebars in the block out for a window, and this is also a full automatic technology. Yeah, in general, CAD/CAM technology, digitalization. We have a system of CAD/CAM means the CAD. Most of you have a CAD system in place, but what's about automation and what happens with those data? And we have an environment around the machine as to be as a link between the CAD system and the automated machines, because all those machines and technology needs data, and the CAD system generates data of the building, and then those data must be panelized, and all those panels then gets into a production planning system where you do the daily production schedule. You determine the order of production to bring them in line, which panel has to be produced when. And having all those in a sequence, you allocate the panels on a pallet or another form. So it depends on the size of a pallet. Is there only one panel on a pallet, or 2 or 3? It depends on the size. And to optimize that, there is automated pallet allocation system integrated in these so-called host computer, and that is the interface between the CAD and the machine. And this host computer then sends the data to each and every machine just in time. And also we have different data necessary, because the plotter needs only geometrical data. The reinforcing machine needs all the information about the reinforcing, but also geometrical data. The concrete spreader needs, for example, what kind of concrete recipe is required and what's the amount of concrete. So we have different data qualities and quantities of data for the different machine, and that everything happens, the distribution of those data happens with a host computer, where you can see it's everything which is blue. That's that part. And here you can see an idea how to use such a computer, not only for machines but also for the workers. Here a paperless production by using large screens at shop floor. So the workers here, they haven't any papers in hand. They just look to the screen, and the screen shows them only those information they need exactly for what they are currently doing. So of course, the screen also can be used for other information, but mainly it's for production data. Yeah, how to get the best results in production or in productivity? Because the question is, which methods, which actions, which machines, which technology is suitable for your individual plant or factory? First, we have to check the current status of your plant or of a plant. Where are the bottlenecks? By time and process analysis. So that needs some time and to identify where are really the bottlenecks. In the circulation line, it's like when you have one truck on the road and many Porsche behind. So the Porsche is only as fast as a truck, and we have to identify where are those trucks. Which processes requires a high consumption in labor force? Sometimes it's not a constant consumption, but periodical consumption. Sometimes you can see that when you cast concrete, then there are 6, 7, 8 people doing casting of concrete at the same time. But that only happens an hour, a day, or less. So what happened? What is the use, or what can they do in the rest of the day? Then to optimize the data, the material, and the workflow. As I said, the easiest achievement, the higher productivity, is to reduce waiting time. Then replacing manual work by machines, equipment, workplace systems, or other technology. And which kind of replacing or which kind of technology, machines or equipment is suitable for you? That's based on the analysis and according to where are bottlenecks. And last but not least, use digital technologies to plan the works, control the processes, and guide incoming, outgoing goods. So using, for example, this CAD/CAM technology really helps just to achieve a higher productivity in this area. And what can we do? Weckenmann and Afinitas can assist you in making your factory future-proof. And here is one testimonial.
I really like how Weckenmann understands the U.S. We could understand where Europe is different than the U.S. How we do things here is different. And Weckenmann understood that. They did not force Kerkstra to adapt to a European model, but they listened and they understood how we manufactured, what our goals were, and it just helped us achieve those goals.
So I thank you very much for your kind attention. Now we switch on to question and answers. And I would like Derek, please go ahead. Thank you very much.
Yes. Thank you, Hermann, for sharing what Weckenmann and Afinitas together can share to the industry to enhance our plants. We will turn over to a couple questions here. I believe we have. second, trying to get them up. Okay, so Herman, first question that we have here is, are there technicians in the US that can come to make repairs?
Yeah, that's a very interesting question. We have 5 levels or 4 levels how to maintain or to support how to do service. First of all, we say make the machine simple and robust. Secondly, make or use parts that are available all over the world. So we use equipment from SEW for the drives, or Siemens or Bosch, or those brands. They do have in the States a lot of partners and even factories to support the user of that machine, just in case get something broken. Then we have a good team of engineers here, and by remote access to the control system, we can help from here, from Germany, to fix it just in case there is something. Then, of course, we have Spillman and Afinitas, just in case there's something gets broken and it needs somebody on site very, very fast. Afinitas and Spillman can assist us. And last but not least, we have service technicians in Germany who can be in the States within 24 hours, just in case. But we have worldwide, we have a lot of installations, and that's very rare that somebody has to fly over because there were no chance or no possibility to fix a breakdown of a machine in a reasonable time frame. Does that answer your question or the question?
Yes, I think it does there, Herman. Thank you. One other question here is, what is the software server requirements needed to run this system?
Yeah, as I said in my presentation, we have the CAD system. In the States, you have different CAD system like Revit or Tekla or Nemetschek. All those CAD systems provide a certain interface and special language to transfer the required data to that host computer. So when, just in case you have those CAD system in use or in place, that's not a big issue to adopt those data to get feeded into a CAD a CAM system or a host computer, or to the machines like a plotter or even a shuttering robot. So, but anyway, we have to sit down with the customer and say, okay, that's your CAD system, that's your digital environment. Maybe you have even an ERP system in place, and we have to sit down, our engineers, to discuss about the interfaces. But there are really no special requirements from our side.
Okay, thanks, Herman. Another question here is, what training is available, and what is the standard on-site training duration time period?
Yeah, it depends on the machine itself. But firstly, normally we install the machines by our team. So we send technicians over to install the machines. to make them up and running, to do the commissioning. And during that process, we want and we like to have operators or maintenance guys from the customer with us to assist us while we install the machine and bring them into production, make them up and running. And also during that installation we do the training, so it goes hand in hand, and we stay we will leave the site only when we are sure that everybody knows how to operate the machine and how to do maintenance. Also, we have a very comprehensive manual along with the machine with drawings and descriptions and diagrams and so on. Yeah, but so how long the duration of a training, that depends on the machine. For example, a power troweling machine, that's more or less easy piece of machine. A CPL machine or even a circulation line, that's more complex, and the training and commissioning or we call it a production guidance, or we accompany the production process for a couple of days or even weeks after we have commissioning happened. So it could be a day for a simple machine, or it could be 3 weeks for a more complex system. Yeah.
Okay, thank you again. Hermann, we had a question there about repairs. Here's another one kind of going in the same regard, asking about are there any parts inventoried, and what parts, if any, are standard repairs typically?
Yeah, so most of the parts, for example, gears, sensors, control systems, most of the things that could get broken, electronic parts are available in the States. So we do not have really storage in the States, because all the machines, not all the machines, but they are custom made, and we are use the first brand suppliers with their network to guarantee that we have all those parts available in everywhere in the US. So it's much it's quicker and more efficient to go that way instead of having that everything inventoried somewhere in the States. And it works, and we have very positive replies from all our customers worldwide doing it this way. Yeah.
Great.
Yeah.
Next one, what kind of maintenance, daily, weekly, so on, should someone expect to have?
Yeah. As I earlier mentioned, make the machine simple and robust, and just to reduce maintenance to a minimum. Of course, when you have a plotting machine or a CPO machine, you have to refill the paint, or you have to refill foaming oil, but that's a question of consumption. But the machines itself do not really need every day a certain time for maintenance. Of course, we have in the manual, it depends on the machine, what kind of machine it is. We have there a schedule of daily, weekly, monthly, yearly maintenance that has to be done. And the daily maintenance, more or less, is just check if everything is in order, but you don't have to dismantle the machine, or you don't have to invest a lot of time. Maybe you have to refill some grease at the concrete spreader once a day, which takes about 2 minutes or so. It's not really a big issue to do that. So we try to make our machines and technology not maintenance free, but to reduce it to a minimum. That's the answer.
Okay, great, Herman, thank you. So that looks like the questions that we have for right now. Just to wrap up here real quick, first of all, I wanted to thank Herman and for his time and for sharing with us today the efficiencies and aid that Weckenmann and Afinitas can give to the precast industry and plants. And also wanted to thank everyone on the call for their time and for their participation today, and leave here with, as you can see on the screen, any contact information. You can reach out to Ted Coons or myself. And last, we will follow up again with a PDF format of today's call, along with the questions and answers and other Weckenmann data for everybody. If there's any further questions, please reach out to us. And again, thanks for the interest, and everybody have a great day.
Yeah, thank you very much also from my side. Take care and see you hopefully next time somewhere in the States. Thank you.